This is the second video documenting the construction process for a timber frame garden shed woodshed. In the previous video, we covered pouring the concrete footings and building the shed sill. In this video, I will cover cutting all of the major timber framing members and all of the associated mortise and tenon joinery. The timbers for this project were cut from hybrid poplar logs using a portable bandsaw mill. Because the timbers are imperfect, we're using the square rule timber framing method. If you're interested in learning more about that, I'd suggest reading Will Beamer's Learn to Timber Frame book. That book includes detailed plans for a small 12 by 16 building. Some of the design elements for this frame were borrowed from that book, and others were borrowed from the timber frame sauna plan I built last year. If you follow my channel, you'll probably notice that I'm putting to use two recent projects. I'm using a set of timber frame sawhorses that I made with a set of holdfasts for holding beams in place while I work on them. I'm also laying out all of my joinery using a timber framing layout template that I made myself. I'll include links to those videos in the cards above. Here I'm laying out a tenon at the end of one of my girts. These beams have already been prepared such that they have two faces that are flat and square to each other. All measurements are made from the resulting reference edge where those faces meet. You can see I've marked that edge with a set of triangles shown here in pencil. For cutting out the tenons, I primarily use a 10-inch worm drive skill saw. I set the depth of cut for each face cut, and then set the saw to full depth for cutting each cheek of the tenon. Once the rough cuts are made, I then use a timber framing chisel to clean things up. I check the tenon offset using my framing square, and then check the final size of the tenon using a simple jig I made that has a 1.5 inch slot cut in a sheet of plywood. Here I'm laying out the joinery at the other end of the girt, which consists of a lap that lays on top of the rear plate, as well as a 1.5 inch tenon that is mortised into the plate. I use SketchUp to create multiple drawing views to which I add dimensions, and then I print those out so that I can take the drawings with me into the framing shop for reference. This lap tenon joint is a bit unusual in that it's an open joint. I cut the inside part using my chain mortiser. I then use the skill saw to make the remaining cuts, leaving the open-ended joint. Finally, I use a chisel to clean things up and chisel things down to an accurate dimension. The gap between the lap and the tenon should be 2 inches, so I check that using one leg of my framing square. The tenon itself should end up being 1.5 inches thick. That I check using my little tenoning template. Finally, as a square rule joint, the tenon is cut to an accurate 5.5 inch width. With the tenons on each end prepared, we then cut the mortises in the girt using the chain mortiser. You may have noticed that when I'm working with the chain mortiser, I tend to stand on a small box to bring myself up to a comfortable working height to handle the mortiser. I then clean up the mortises using my framing chisel and check for accurate depth and width using the 1.5 inch arm of my framing square. In the square rule framing method, most mortises are housed, and I use a plunge router with a straight bit to cut away some material in the housing. Here I'm cutting back to a measurement that's 5.5 inches from the opposite reference face. And then finally I'll chamfer the post edges using a trim router for large chamfers, or just a block plane if I'm putting on a small chamfer. When it came time to finish, this is just a woodshed, so I chose to leave the beams rough, but give them a quick polishing with an abrasive brush on a polisher. For finish, I applied a coat of a mix of linseed oil and D-limonene before assembly. At this point, most of the major structural timbers are prepped. I've got my 3 posts cut, the 3 long posts, 3 short posts. All of the joinery is cut on the posts. I've cut my 3 girts, and the joinery is all cut in those. And I made a couple of big mistakes. I had 2 first inclinations. The first was to chuck the whole beam that I made the mistake on and start over. I decided it was a lot of material to waste, so I didn't do that. My second inclination was to hide this part in the video and not tell you about it. But I decided that mistakes are probably as instructive as doing things right. So this girt I messed up. I had an old drawing that had a mistake in it, and this mortise pocket was supposed to be 24 inches from this reference face, and I cut it 20 inches. Many of the short braces do have 20 inches from the bearing face to the reference face. These 2 are supposed to have 24 inches. So these 2 girts are actually supposed to be identical. So this one we're 24 inches from the reference face. This one I cut 20, so what I did is I just extended the pocket to 24 inches. This is the bearing face structurally of the brace, so I don't think it's the end of the world from a structural perspective. I'll put a little 4-inch filler block in there. I'm sure it'll hold up just fine. The more serious mistake I made from a structural perspective was I cut this tenon in the wrong position. It is supposed to be 2 inches from the reference face and then a 1.5 inch tenon, because it fits in this mortise pocket, which has a 2-inch offset and then a 1.5 inch pocket. And I did this one right, and this one right, and this one I cut it 1.5 inches, because many of my tenons are 1.5 inches from the reference face. This one should be 2, so I had 1.5 and then a 1.5 inch tenon. I didn't have much choice but to cut away 1/2 inch, so I now have a 1-inch tenon. I'll put a little filler block in here as well. And I might have worried about that from a structural perspective, but this shed is so overbuilt. It's a 8 by 12 foot shed built out of 6 by 6 timbers with mortise and tenon joinery, so I think it'll hold up. Plus, this tenon actually sits on a housed mortise, so there's a face there for it to bear weight. So I'll put a little 1/2 inch filler block in there. If I were concerned, I could cut back in and recess the material and put a pin through it. I just don't think it's necessary for this. So made some mistakes, but I think we can recover from them. And again, this shed's so overbuilt that I think it'll still stand up. So there you have it. So after I finished cutting all of the posts and girts, I had to lay out and cut the joinery for the 2 long plates that sit on top of each wall. The plates are 6 by 8 inches in cross section and 14 feet long. The joinery in these is a series of simple mortises. These were laid out and cut using the methods described earlier. So I think I'll wrap this video up here. In the next video in this series, I think what I'll cover is making the knee braces and maybe doing a little bit of a test fit there. I hope you'll follow along. As always, thanks for watching.